CSMA-CD is part of the Ethernet protocol. It is part of, in fact, it is defined in the 802.3 standard. So it is a sub-protocol, if you will, of the Ethernet protocol. Let's take a look at what it stands for. CSMA-CD stands for Carrier Sense Multiple Access with Collision Detection. So if we take a closer look at that name, let's sort of analyze it. Carrier sense. So this means that the host can sense traffic on the wire. It's capable of hearing that traffic in the form of voltages on that wire. Multiple access means that many hosts can share one wire. So in this case, we're talking about a whole bunch of PCs all on a wire, maybe connected with a hub or connected on in a bus formation, all wanting to share this same wire. And finally, collision detection means that the hosts are capable of detecting and reacting to collisions. In other words, the voltage is not the normal voltage. It will see a higher voltage. When it sees that higher voltage, it knows that a collision has taken place and it's capable of reacting to it in some way. We call this contention, this idea of multiple PCs trying to use the same wire. So within a collision domain, only one device can be talking at a time. If you put another device on that same wire, the voltages are going to collide with each other and you'll have this collision. If another device tries to talk, two devices at the same time, does that ever occur? Yes, it does. In fact, it occurs quite frequently. And the more PCs you put on that wire, the more often collisions occur. So we call this conflict contention. The more contention we have, the more we have to retransmit stuff, and so the slower the communication. And it can go quite rapidly. You get 10 computers or more, and it starts to decline rather quickly. Remember that CMSA-CD is only a reference to wired communication, Ethernet. It is not a reference to wireless systems. Wireless systems have another method that they use. In fact, it's called CSMA-CA, but that's beside the point at this point. But CSMA-CD is only a reference to wired communications. Let's see what that process looks like. First of all, the host that wants to communicate, it wants to send out a frame, listens to the wire for traffic to see if it can send that frame or not. If the wire is clear, if it doesn't detect any voltage on that wire, it can go ahead and transmit the first bit. Now it listens at that point for a collision, a voltage spike that's higher than the voltage that it put out. And if it sees that voltage spike, if it does not see the voltage spike, then it goes ahead and sends the next bit, and so on. If, however, a collision is heard and it sees that big voltage spike, then all of the hosts will sense that higher voltage spike and they will all back off and wait for random periods of time. There's a randomization feature in CSMA-CD that sets different times for each host. And so as those timers expire then, each host will go back to step one and start listening again. And hopefully that will have taken care of the problem. There is a flowchart that you can look at, and I will have the link here by the time you see this video, and I will also have a link in the video description as well. Remember that CSMA-CD is a layer 2 technology. We're talking frames here. We're not talking packets. We're not talking segments. We're just talking frames. So this is an Ethernet technology, a subcategory of Ethernet, and so thus a layer 2 technology. Well, that's it for CSMA-CD.